Okay, so I would like to say good afternoon to everybody. I know we have a lot of people from the UK, but we also have some of our customers from abroad that have logged in already. So good to see everybody. And as I say, thank you for joining us today for this exciting webinar. I'm Stephen Judge from Bracon, and on behalf of Bracon Limited and Saremco, it's my pleasure to welcome you all this afternoon to the Saremco webinar. I'll just say a few words and then we'll pass over to Jeroen to get started. Historically, I guess we've all thought of resins as being used as temporary restorations and particularly for restorative dentistry. And as you will see, as Jeroen goes through the presentation today, that is now very outdated thinking because we now have these fantastic Class 2A permanent materials with incredible aesthetics that give us a whole range of further options. So that's permanent crowns, veneers, inlays, onlays, can all be printed in a Class 2A permanent resin, and that's alongside prosthetics as well. As I said, Jeroen will take us through these exciting materials today, and particularly Crown Tech and Dentiq. And if you have any questions, please could you either put them in the chat or just save them to the end of the session, and then we'll try and get through as many questions as we can. I'll now pass you over to Jeroen, but in the meantime, could I please just ask you to mute your microphones so we don't have a lot of feedback as the presentation starts. Thank you very much, and I hope you enjoy the webinar today. And over to Jeroen now. Thank you.
Thank you very much, Stephen, for the introduction, and good afternoon, everyone in the UK. For us, it's a late session, actually. It's midnight here in Australia. It's a long day. Hopefully, the internet line doesn't lag too much. We're far away, the other side of the ocean, other side of the world. But fingers crossed, everything goes well. Hope everyone can see and hear me clearly. Again, thank you, Stephen from Bracon, for the chance to speak to you all, also together with Saremco. And today we got a great topic, and that's really cost savings and aesthetic possibilities when we include 3D printing resins like Saremco. Let me tell you a little bit about myself. I don't like to talk about myself, but I do think we need to. So, a small introduction about myself. My name is Jeroen Klijnsma. I'm a certified dental technician and a digital dentistry specialist. Born in the Netherlands, that explains my accent, so don't shoot the messenger. And never judge a book by its cover, so don't get fooled by the beard and the tattoos. I'm a friendly guy. You can ask me the questions and I will help you as much as I can. I'm currently living in Melbourne, Australia. Whoever has been to Australia, well, you got a good alliance with Australia, of course. Melbourne is the city of the best coffee, I think. So absolutely come by and be welcome at our facility. I am since 2005 in the digital dental industry. I was one of the very first in Europe who started to work with scanners like 3Shape, mills, 3D printing. We were an absolutely early adapter in all these type of technology. And actually that made us also KOL, and KOL, key opinion leader, sounds very interesting, but it's a lot of hard work to work with all these companies. And I'm a KOL for Saremco, but also for other industry leading companies. Think about Asiga, Nextend, all the big printing companies actually are is actually a partner of us, and we do a lot of great work together with them. The reason actually why I started the company Dentiq is when I moved to Australia a couple of years ago, I noticed there was a massive gap after the reseller. And so Not so much that the resellers don't do their job correctly, but it's a job of the reseller not to take you by the hand and really guide you to all the workflows. That's where I come in, and really because I've had those many years of experience. So I actually started the company Dentiq, and Dentiq stands for Dental IQ. And for some reason my presenter doesn't work. Let me see. So who is Dentiq? Dentiq Dental Services. Well, we're a training and consultancy agency. So all our knowledge we try to share. We're a dental laboratory and we have a design service. And we support dental specialists like you, clinicians, prosthetists, and dental technicians. We've got over 18 years of experience in digital manufacturing, from subtractive like milling to additive manufacturing like 3D printing. We do a lot of research and development and a lot of workflow optimization worldwide. And actually today we want to share our knowledge, the knowledge we have gathered in all these years. Together, we want to share that with you so you can really use that and create better services in that way. But enough about me. I don't like to talk about myself. I really want to share with you the great things about these materials. So if you not 3D print or you haven't started yet, really the moment is absolutely there. Anyone who says digital isn't there yet is just because they are afraid to make that step. Like I said, I've been doing it digital for over 18 years. And yes, it's falling, redoing things, learning. But if you don't feel you haven't tried, and this is really one of the things I always say. And so now is the moment to really start with digital dentistry. All the technology is there, all the accuracy. So when we 3D print, we got a couple of initial benefits. And the benefits, it's an entire list, but I want to go over a short list. And one of them is we want to work with a very high accurate technology. Everything we do, we talk about microns. And with 3D printing, we can really achieve that. And a lot of studies have been made that actually if you do control the entire process really well, your outcome of 3D printing is actually even more accurate than subtractive, than milling. So what happens also is we want to minimize the amount of human error. So everywhere we do things with our hands, we can make mistakes. And what is the best tool we have, the best friend in digital dentistry, is actually the undo button. Another thing that is quite important is that we don't have to pour up plaster models. We all know we pour up a plaster, we wait 20 minutes, an hour, and everybody starts working on it. But to really start working on proper plaster models, you have to wait a much longer time before everything has been set. The chemical reaction, the humidity, and well, I don't have to explain, you guys, we're all dental experts like that. But the benefit when we do 3D printing is we can, after a scan, directly make a model, or actually already start making something without a model. So, and also reproducibility. When anything goes wrong, we just have to press next. We're ready to go. We can make something new. Another great thing is you can promote yourself as state of the art. And how cool is it that we can really say, we have the newest technology, we can provide you the best service. And this is actually kind of a little bit of a joke, but I do think it is very true, as it performs on Monday the same as on a Friday. And why do I say that as a little bit as a joke? Well, at the Thursday, Friday, we're already with our head like, oh, it's nearly weekend. Are we going to see family, friends, barbecue, party? You name it. So your mind is already somewhere else. But on Monday and Tuesday, you're still recovering from the hangover of the weekend. Of course, a little bit of a joke, but I do think there's a certain type of truth in that one. And we're really productive, really midway the week. And if we treat our digital equipment like our 3D printers really well, we keep it clean, they treat you well. Okay, what are a couple of other benefits? And this is compared actually when we compare it with subtractive. And don't get me wrong, I'm a big fan also of milling, but there are a couple of limitations. And if we mill something, we have milling dust, for example. So we don't have that when we 3D print. We have no noise, no broken burrs, no maintenance costs really, because what's there to maintain? No consumables except for the trays, of course, and the resins. We don't need a high-end compressor. We don't need an expensive vacuum system or expensive CAM software. That's all technically included. But the biggest benefit I see is we don't need any drill compensation. So the ones who are milling, probably they know what it is. If you don't know what drill compensation is, let me help you a little bit on that one. Is when we have drill compensation, we have, for example, if we have the top, and I'm drawing it without my hands over here, so hopefully everyone can see. If we have a beautiful preparation, let's say this is an anterior preparation, and the incisal tip is quite pointy like that, and we have the inside of the restoration, inside of the crown, the milling burr needs to go all the way in there. So to make sure that the crown fits beautifully on the preparation, on the die, in that area. But we are limited by the size of the milling burr. So let's pretend the milling burr has a diameter of 1 millimeter. That means that when it goes up and it already touches the side, it doesn't go any further. So that means the crown doesn't fit all the way down. So what is the software doing really with drill compensation? And this is actually something we do in our CAD software, where we design, is we add the drill compensation. That means we create an extra circular area, so the milling burr goes actually a little bit further in the preparation. So that means then when the preparation, or the crown goes on top of the preparation, it goes all the way down and it fits properly. However, there's one big disadvantage, is if we have a drill compensation, or wall thickness, and hopefully you can see that on the left side, is much smaller. So let me see if I can show this area here. That is much smaller. Suddenly, instead of having this entire area, we only have this little area. That means aesthetically we have created a black spot or anything. And and that's the benefit when we 3D print, we don't have this. We have full amount, we have the full thickness of the material, we can create better aesthetic cases, and especially when we're looking at veneers or thin crowns. Hope there are no other questions about that. So let me go to the next section. So let me see if I can erase the clear all drawings. Yeah, there it is. So what can we 3D print in dental? Well, there are a couple of things we can 3D print in dental. And when we start 3D printing, we all start with the first thing we do is actually we make models. Why do we make models? Because we can work without models and everything. Yes and no. Yes, if you control your workflows, your settings really well, you can do that. But I'm still a big fan of checking my final work. Look, I don't get my margin from a digital model. I get my margin out of my digital scan. But it is just to make sure the contact is there. And not only that, is when you deliver it on a model to your client or anything like that, you can show, hey, based on this information, I've made a product that fits and that works really well. So that's why we still make models. Another thing, we can do models, for example, for diagnostic wax-ups. We can do a motivational wax-up or even a functional, when you use that, make a guide over it or an extra clear and use that during the treatment. Another thing we do, for example, still is custom trays. Custom trays are still a very popular product. One of the better products we have actually later on is also, we do RPDs, for example. We can cast them, we can print them already in the metal, but I'm a big fan of 3D printed splints. And we, in our own facility, we do actually a ton of splints on a weekly basis. And digital technology allows us to make really predictable, great splints. Models for clear aligners, for example, and then do a thermal forming or a shock down over it. The other one is that there's a new technology that is called a direct aligner. So the aligner itself is already 3D printed. The technology is not 100% there yet, the strength not, but this is something a matter of time. Any of you are, I assume any of you are actually using surgical guides. We can easily design our surgical guide, 3D print that one, put in our sleeve if we work with a sleeve system, and directly use that. Crowns, temporary, Long-term, permanent is a word I don't like to use that much, because who can guarantee something that's really always there? So I prefer to call it a long-term product. All on case, we talk about this a little bit later more in detail, and especially, of course, dentures. So, like I said, we're going to talk a little bit about more possibilities, and one of them I'm a big fan is, for example, the temporary / long-term crowns. And we now have a material, and directly I want to bounce or basically go on to the Saremco, is they've created the next generation hybrid resin. And this is a resin with a lot of glass or silica particles actually in it, and that gives it the strength, very close to natural teeth, but especially a very high aesthetics. So we can really make really good aesthetic looking crowns. And because it's a class 2A approved material, it is for long term, so you don't have to worry about that. Another thing that we can do, for example, is a lingual retainer. This is a lingual retainer in a Snow White, because we are not limited by shapes that we use when we are, for example, milling. And the geometry limitations, we don't have that with 3D printing, so we can already make a retainer that fits really, really well. A big fan, I'm also about full arch, multi-unit abutment or direct to fixture, depending on the implant system we are using. For example, you've got our, this is the TRI implant system, is a great system. You can do direct to fixture. Otherwise, you got your MUA. You can really 3D print it and have this in the mouth for a long period. So also to check if whatever you have done is been done correctly. And in this case, I've just individualized it a little bit with some Dentiq, the Dentiq base resin on the outside. I applied it manually. You see that on the right picture. This is just as a demonstration how we can work with that, but really applied it manually, light cured that, and aesthetically finished it like that. And this is a great way of having directly a full arch restoration. So what also is definitely a hot topic in our current industry is dentures, immediate dentures, or the final dentures, the full. The good thing about Saremco is they created a toothed material, had the crown tech that is already very aesthetic, but it is very compatible with the Dentiq base material. It's in the same range of the composition of the materials, and we are able to create a fully aesthetic denture. The denture you see on the screen, this is the case that has just been completely polished, so no individualization in coloring or anything else. And by just printing the base, printing the teeth, merging them together, we were able to create very aesthetic dentures like that. And this is for us a great solution, if especially when we do, for example, community healthcare, for people who can't afford that and they still need a great denture, and still you want to give them something aesthetically, it's a great solution. So why use Saremco? Well, there are really so many reasons why we can use Saremco. And one of the things is, let me go over the list why Saremco is so great. Because it is a medical device, and in Europe and the US it's classified as a class 2 or class 2A. So it is suitable for permanent crowns, onlays, veneers, and so on, denture teeth, temporary bridges, etc., etc. What I do find important, especially about this, that it is, for example, CE or MDR approved, an FDA clearance, and in Australia we've got the TGA. The good thing about this material, and this is where really Saremco excels, is biocompatible resins, holistic resins, holistic materials. And like I said before, it's a silica glass infiltrated microfilled resin. So the amount of particles in there is so high that it behaves very like natural teeth. has quite a lot of aesthetics, and especially when you're going, for example, more to incisal area where it becomes a little bit thinner, light transmits really well through it, so it also has more the aesthetic appearance. So in a lot of cases, when we 3D print something or when we actually make something, the materials are very monochromatic and everything. And with Saremco, we don't have that problem. It is very easy to finish quite aesthetically by using anything like an else paint art or GC OptiGlaze, for example. It's just something on the outside, but it does give you the right aesthetic features. The average net flexural strength of that material is about 135 MPa. That's very close to natural teeth. So it's not so abrasive, and it works really well. The modulus of elasticity is about 4000 MPa for the teeth. And you don't want the teeth to flex too much, and that's not good. And so the higher the number of the modulus of elasticity, the higher the number, the more stiffer it is. So this material is really approved for a different type of printers, and we go over the printer list a little bit later, but we're able to print this in wavelengths from 385 to 405 actually. It is currently available in 5 colors: A1, A2, A3, B1, and an SW, and an SW stands for Snow White. American White, whatever you like to call it. The shelf life has definitely been improved. That's up to 4 years at the moment, and they are being sold in 500 grams of bottles. Because it's a little bit of a thicker resin, it is very good that it's already very well mixed by itself, and it just needs a minimum amount of shaking time. It's easy to print. I can print it on every printer I've got, and I've got at the moment nearly 25 printers. And on the majority of these, it's all approved. And custom staining, like we use else paint art or GC OptiGlaze, is definitely possible. Then we got, of course, the Dentiq Tech. That's the Dentiq base material, and that is in Europe and Australia only approved, not in the US, as I understand at the moment. But it is also biocompatible, and especially non-elongating in moisturous environments. That is very important. Also very aesthetic, easy to adapt, easy to polish, and everything like that. An average flexural strength of 100 MPa. But here again, the modulus of elasticity is so important. So again, I said, the higher the number, the more stiff it is. So we want a little bit of flex in the Dentiq base so it doesn't immediately break. And a lot of new things are definitely coming, so keep a close eye on that one, to be honest. So if we compare it with other materials on the market, this is from a company called Dentiq, for example, is there you can see that the bending factor of that one is, for example, 115. So the strength and the modulus of elasticity is 3500. There's a little bit more flex. It is in a similar range of colors available. And another one we have, for example, is this is a material that is being in the market delivered by Sprint Ray, but here you will see the flexural strength is about 100 MPa. So that's actually even lower than that. So one of the things I do find important is long-term information. Everything we do new is everything like, oh, but there's no long-term information available. Well, yes and no. So one of the things that Saremco did really well is done a proper 10 years chewing simulation. And what does that mean? Well, they did a number of cycles of 2.4 million. Most of these manufacturers, oh, we've got a long-term chewing simulation. They tested 300, 400,000 times. I'm like, that is not even a year of chewing. That does not make sense. Also, what you see over here is that before that test, hey, you see the strength, 2150. But if we have been using that for a longer time after all that chewing, you see it's even a little bit stronger. And that tells me that the material can last much longer and it can withstand these long-term chewing simulations, and it compacts itself almost a little bit. What I do find important with all these numbers is the following, is measuring is knowing. And why do I say that? Well, we are having two types of measurings in the world that we use. We've got the standard, the ISO 4049, that is really a standard we use for 3D printing materials, 3D printing plastics in dental. And this is the right way to do it. Actually, a lot of companies use the ASTM standard, and that is actually a measurement that is for non-dental plastic, for general plastics actually. And those values are actually look way more interesting, but they're actually not completely true, because you're not comparing really what is what. So be careful that a lot of times we see things being promoted that are not always the right thing that have been promoted, or they're not always saying the right thing. I know, and this is one of the reasons why I'm working over 4 years with Saremco, is these guys do the right thing. As a Swiss company, they have to be very strictly monitored, but they do the right thing, and they are specialists in these type of materials. So for me, it's very important. Measuring is knowing. And it's all great, all factual information. And look, trust me, Dentiq is all about factual information. We don't favoritize any brand or anything like that. We just work with brands we really believe in. And Saremco is for me definitely one of them. But why? Why do I use Saremco? Well, I've seen it with my own eyes, and I want to share that with you today. So I'm going to show you a couple of cases we've done. Some of them are on the bench, some of them are clinically wise. You judge for yourself. You judge if you find that aesthetically yes or no. I can find it the most aesthetic, but I'm not here to convince you like that. I think the results will convince you automatically. So I always say leading by aesthetics. And this is a crown I printed in A3 resin. I've done nothing to it. Just comes out of a machine, and I think we're very close. Just an A3 is an A3. Of course, the more thicker the material, the more chroma we have, for example. Here, also one case we've done, we warmed the neck up a little bit and then gave it a good polish. Another A3 is A3. Also nothing too special, but you can already see quite nicely going from incisely towards the base head, the dentine area. It is really quite a nice transition. This was actually quite an interesting case. This was an implant case that was fully holistic. So the implant was itself in zirconia, the abutment was in zirconia, the screw was in carbon fiber, and on top of that we've printed in a holistic material, Saremco, and so we've got a basically completely metal-free restoration. Okay, if we're going to be very technical, yes, zirconia falls under the metal, but it behaves like a glass ceramic. There's so much more to it, but I thought this was a really great solution for this type of patients. Another one, we did an A4. By using an A3 and warm it up a little bit, we had really great aesthetic results. Actually, the one I'm showing you now is actually a case we've done this week. This was a temporary crown on a temporary cylinder, so please forgive me the screw hole. In this case, we had to, because the implant was very deep, we had to use a temporary cylinder and scan that one, and on top of that made a crown. This is a choice also by the clinician to have that screw hole just labially coming out there. It's going to fit it, stay in there for a while, and see how also the tissue behaves. Underneath the tissue, it is there is no coloring like an OptiGlaze or anything. That's only polished. So we have no influence or not being influenced by any coloring material or staining material like that. We got directly the pure material. In this case, we make sure that we have a beautiful integration with our tissue. A simple onlay. This is an interesting case. Is it the most aesthetic? Definitely not. I will not say that. But what we did, we had a patient who wanted to keep her own teeth, but her teeth needed to be extracted. But she wanted to keep the shape. So what we did in the computer, we had the scan digitally, removed it, designed an acetal framework. We milled that. We took the teeth we already had. We copied that. We 3D printed that. And we cold cured like that. And the patient was really happy. There was no fitting stress or anything, and no ugly metal clammers. Look, are these better ones? Who am I to judge? Still not the most aesthetic case, but I do think that here 3 different technologies combined really, really well. Another case, this is actually one of the cases I'm very proud of. This is in a B1, is here we didn't use anything but just relief, so grinding and polishing, and no staining or anything, and we created a beautiful integrated central. This is one of them I'm very proud of. Another one, this is made by the University of Zurich, a temporary bridge. I would not recommend to make a bridge that great looking, because you have a chance the patient is not coming back. But I have to give my compliments to the University of Zurich, because they really created a nice aesthetically looking bridge. This is one of the cases that one of my clinicians actually did. This was for a patient who had bone cancer in the jaw, so they had to remove a part, took a little part of bone out of somewhere else out of the body, and all put it back in. And you see those metal hooks. Those are basically loops to keep that bridge more in place. And that stays for about 1.5 years to 2 years in the mouth before we go into the final restoration. Actually, very impressive case like that. If we cover the inflammation of the tissue on this one, this is also a 2-1, one of the centrals we did, and also by 3D printing, just a bit of custom staining. I think we have really great aesthetic results also like that. So you definitely see, with a little bit of creativity, you can get great results. This is a case also from one of my clinicians, was also a temporary case, full upper prep, so full arch upper. We really 3D printed that by just a little bit of polishing and contouring. I think we've created really great aesthetic results. And we let the patient walk around with this a couple of months until they're fully happy and they're like, you know what, let's go into the final. So I definitely think we have hopefully shown you that with this type of resin and with the Crown Tech, we can really achieve great aesthetic results. So to understand what we can do is we need to know how and what kind of printers they are, the resin is usable. And for example, we have a validation overview, and the validation overview shows you all the printers that are validated. We've got the Accurata printers, the Asiga, Dentiq, Desktop Help, DMG, Haygears. Well, I can go over the entire list. Nearly all of them are also partners of us. And there is suddenly a poll popping up on my screen. That's not for me, I think. So there it is. Actually, they just also announced that Nexa 3D has been added to that list. And on the right side, you see what light curing unit has been approved. And light curing is also something that is very important, because that belongs to your post-processing. And that is something I want to talk to you about a little bit now. And post-processing is so important. So what is really post-processing? Well, we can have a most beautiful design. We can have the best printer. We can have the best resins. Yeah, we've already shown Saremco is one of the best resins. But if we don't do the post-processing correctly, and that is the steps afterwards, so the cleaning and the light curing, everything we've done up front has technically failed if we don't do these steps correctly. So post-pressing, why do we do that? Well, we do that for a couple of reasons. So we do that to clean the objects from any uncured resin. So once the printing is finished, the platform goes up, there is still resin on my crown. Well, let's say we print the crown. So we want to make sure that excess resin, that uncured resin, is going away. And we want to do that so we can create an accuracy on the X, Y, and also the Z dimension. So we want to make sure that what we print is really the object and nothing of the resin around it is going to be also cured, and that makes the object bigger, for example. And we also do the post-processing, the light curing, to solidify the object even more. So once we 3D print, it only solidifies that little layer, so it's stackable. It's not fully cured yet, so the photopolymers, the monomers in there, are not fully set yet, so it's very important that we do that. And we all do that to make sure we comply with any FDI, CE, MDR, or TJ regulation, or what kind of regulation we have. So if we want to clean, there are a couple of options we can do. For example, if you are in a clinical environment, you can use an automated system. For example, this is a tornado system that is an A and a B. You can put it in A first and then in B, but it's more automated like that. There are fully automated systems also available that it mixes itself, gets a cleaning solution in there, washes it, takes out cleaning solution A, puts in cleaning solution number B, and so on. Or what you can do is something like in a lab environment is use, for example, an ultrasonic, and that's called a two-step rinsing. We have a Kmart, for example, we have those small 500 milliliters of containers. I think 2 of them cost about $2.5 Australian dollars, or 3 of them actually. That is basically nothing. So I put the name on it, let's say Saremco Crown Tech A and Saremco Crown Tech B. So I first wash it in A and then I wash it in B. So in this way, I don't contaminate anything. And I'll talk a little bit later about that. So, but how can we clean? Well, we can clean in 2 ways. We can clean with an IPA. IsoClean, for example, is an IPA. It's widely available. It's a low cost. IPA is not expensive. It vaporizes. It's a potent smell. That's the downside. Like if you want to start your weekend well, you only use that once, so be careful with that. And it's flammable. That is something that is actually something we have to think about. If we don't want that flammable material around us, but also something that has a nicer smell, you can look, for example, at the cleaning concentrate that Saremco just released. And the good thing is, because it's a concentrate, you can make much more with it. So 3 liters makes basically 17 liters when you mix it with demineralized water. And the good thing is, because you have so much, or actually so less of the concentrate, you save a lot on shipping. So instead of every time shipping 17 liters, you only have to ship 3 liters of that one, and water is easier to get. So that's a great solution. So one of the things when we clean a Saremco, we recommend to clean it with, for example, the easiest way is with the concentrate. You just put it in there 2 times 3 minutes, not longer, not shorter, and it works really great. So you do a washing A and a washing B. That works well, and you can submerge completely your product inside the cleaning material. But if you want the best results, you can do it also by hand. And what do I mean best results? Both work really well, but this is a little bit of more manual work. So you can't submerge the Crown Tech material completely in the IPA. You just brush it off with a little bit of micro brush, for example, or a tissue that's been drenched into some IPA. And then air dry it, or with an air gun or anything. So you want to minimize the contact with IPA, because if we do that, if we get in contact with IPA, you will see later a little bit what's happening. But what I want to touch base first is actually when we just freshly printed, you see it's still wet on the surface and on the inside. And if we don't clean that properly before we do the light curing, we actually cure material that's still there. That means the object is bigger, and especially when it's in the fitting surface, your crown or object will not fit. So when it's properly cleaned, you want to make sure it has almost like a matte finish. Then we definitely know it's properly clean. There are no shining parts anymore, because if it's a shining part, it's basically like a water drop and if you shine your light on it, it reflects. It works a little bit the same. So you want to make sure it's a light matte finish, and then you are actually quite sure that's properly cleaned. So if we submerge something fully in IPA, and I said that a little bit before, we get these type of results. And this is what we see quite often with filled or hybrid resins. Oh, they say, yeah, submerged in IPA. This is what's happening. That filler that reacts, the silica glass, those particles react actually with the IPA. Yes, you can get rid of it, but it's a lot more extra work. And is that work you really want? No. So please don't submerge it in IPA. And why are all these things very important, and especially why I have those, for example, those two containers, is when we 3D print anything that's biocompatible. And what is actually biocompatible? A biocompatible material is actually something that doesn't give an allergic reaction or a toxic reaction with human, because it's on the body or in the body or anything like that. And we don't want those type of reactions. So I can't mix and match materials. For example, you've got your classification 1, classification 2 or 2A. You can't mix that, because if I put a classification 2 into the same cleaning solution as a class 1, like a splint, for example, I already violating my class 2 validation. Especially, for example, with models. If you have your cleaning station and you put models in that, and then you want to put a crown in it, you can't, because that crown is now contaminated with that model resin, and that model resin has not been approved for the mouth. Hope that makes sense. So really think about that, ask your reseller, do your own research about that, but keep that very separately. And that's so, so important. So one of the other things is light curing. So like I said before, the printer does nothing more than solidifying those layers so it's stackable. And really, we want to make sure all the photopolymers, monomers are completely set and everything, and it's all properly done. And it's so important that you have the proper light curing unit. And some light curing units are better than the others. For example, there are a couple of light curing LED light curing units that do a great job, but some people were saying, oh, but my crown doesn't have the right color. No, that because of the wavelength range of that light curing box doesn't fall completely in there to get the right color. And why am I saying that? Because this is the great thing about Saremco, and let me go directly into this one actually, is when I do the light curing and the post-processing really correctly, I should have quite soon the right color. If I have not achieved the right color, then that means there's something missing in my post-processing, and this I like to call the DNA of that material. So if I want to get to the right color, even though I have fully light cured with an approved light curing box, but that wavelength doesn't reach that level, so it's immediately the right color. It doesn't mean it's not light cured properly. It's still safe and everything, but the color is not there yet. It can take a while. How you can speed that up, for example, is using an autoclave. You can put it in an autoclave, 5 minutes in an autoclave on 134 degrees. That works well. Or what I'm doing is I just do it in water. I just boil water, put it 2 minutes in boiling water, and it comes out and I've got the right color. And this works really well. So instead of waiting, so when we started with Saremco in the beginning, we didn't do this part yet. So it was not known to us that widely. And we were like, oh, it doesn't, yeah, but it takes a little bit, takes a couple of days. Yeah, but I have to deliver a case. So we came up with an entire process, and it's the autoclave and the water bath, and that works really, really well. So if we finish, for example, it is also very important that we do some coloring. For example, if we want to even make it more aesthetic or some additional glazing, we can use an Else paint art or an optic glaze, works really well. Or when we do a polishing, we can do a hand polishing with a hand piece, or we can use a buffing lathe. That also works really well. One of the things I do want to talk about to you is some PPE and safety. So when we 3D print, make sure you print on a stable surface or a table. And when it's wobbly, it moves, it's not safe, you can spill something. And make sure, I've got, for example, all my printers on stainless steel benches. If I spill some resin, for example, I just use a little bit of alcohol or IPA. I spray it, wipe it, and it's done. It's clean. Work in a well-ventilated area. Use safety goggles. I prefer that you use nitrile hand gloves, no latex. Well, why no latex? Well, latex can be a little bit porous or have some porosity. It's less strong, and it also can react with some of the printing materials. And just use something like a lab coat or anything. Never wear your good clothes or shoes when you are 3D printing. So I quickly want to swap a little bit, and hopefully I can quickly share that screen with you. And for some reason, yeah, screen 2, share. Hopefully you're able to see. I've got a camera. I'll walk a little bit out of my camera actually. We've got a camera, hopefully you can see it. Is some of the examples we've done. So you've seen the denture we have. It's a really aesthetic looking denture. It is only polished, nothing done to it, and just printed the base, printed the teeth, and we're ready to go. The same is smile in a box, for example. This is the full arch, direct to fixture, for example. This is based for a smile in a box for I believe Straumann. Yeah, it's a Straumann system. My apologies. On temp cylinders, so this goes in temporarily, so they can fixate these points on the fixation pin, have temporary cylinders in there, and fixate that chair side. When the patient is still fully under, and patient walks out with a smile for a while. Saremco has got some great shade tabs and everything that you can really work well with that. And everything like that is possible. The crown we made, it's a really good aesthetic looking crown. I hope everybody can see really how it looks. So when I can show you, for example, I've got a 3D printed crown here. Hopefully everyone can see. It's still dipped in resin. It's still completely wet. So what we use is, I've got, for example, a little bit of IPA in here in a little container, and I can use a little bit of a micro brush, for example. I can do that. I can completely clean that, easy to clean. So just dip it in a little bit of IPA, just rinse the inside properly, air dry it, and everything like that. So one of the things you can use is a properly approved light curing unit. And when I finish anything, I use, for example, these are my main tools that I use: a 3M Scotch-Brite to take away any little support pins, little rubber, and just a polishing wheel. And I can use some polishing, high shine polish compounds to make that work. So let me go back to the presentation actually. Hopefully everyone can still see. So a lot of times I get also the question, yeah, but what are the costs? What are the costs of printing something that is Class 2A approved, so that we can use long term also? Well, if we're going to look at purely the cost, it's actually not too bad. And I had to, of course, do the conversion to the British pound. But if we print normally models, we're roughly looking at £2 a crown, less than £5. And actually, if we do a more proper calculation, it's actually between £1 and £2 that we do for a crown. So it's actually not so bad. When you buy a bottle, yes, you buy 500 grams, and yes, you pay a certain amount of it for it, but the amount of units we can do with just that bottle is just absolutely insane. For example, I can get 200 to 50 crowns maybe, small crowns out of a bottle. It's actually quite good. So the cost per unit is actually quite low. Splint is on average, we don't print splint with these materials, but when we 3D print splints, roughly about $7. But if we look at the denture, for example, it's only on material wise, and this is, for example, just an upper denture, 15 pounds. So roughly 7 pounds for the base, 7 pounds for the entire arch. And if we combine that, 15 pounds. If I am using carded feet, for example, that will be roughly, let's say, a set of, I think, Ultra, let's give a name. What would it be? 100 pounds, maybe? I think I have to do a quick conversion, roughly like that. Plus everything else, the other materials, you are way higher than when you 3D print it. Not only that, is yes, your aesthetics might be a little bit different, but what is the strongest part in a denture, or actually the weakest part, is the single tooth. And in this case, you've got a full arch, and that is much stronger in that way. So there are always pros and cons, and people have always different visions and everything, but I'm just purely factual on these. One of the things I also want to touch base is actually when we do something like that, it is very important that when we are in digital dentistry, that we chose the right things. And what do I mean with the right things? Well, we need to have the right software. We need to write the CAD software to design it, for example. We use 3Shape, Exocad, Blender for Dental, Mesh Mixer, Medit, you name it. There is an entire list of software that we can use. We use the right hardware. Make sure you've got the right printer. You've got an Asiga, or you've got an Nexa 3D, or whatever printer you're using, and that is validated. Also use the right materials, and right materials that are approved in your country is very important. So also do your own research. Go to the certified resellers and say, okay, what are the options? What can we really use in our country? And it's very important to choose your right partner for information and support. When I started 18 years ago, there was nobody who could tell you anything. So we had to do everything ourselves. So we were not able to get a fully certified workflow yet, because at that time that wasn't there. So if you use the right partner, you have all that information. And when I started, really, I'll show you actually my first 3D printer. And this is my first 3D printer. Of course, a little bit of a joke, but printed 3Ds. But yeah, when we started, we didn't have all that advanced knowledge that all the resellers have, like Bracon, for example. And so I do find it very important, like, hey, make sure, because we all need support. We all need to ask our questions. We don't know everything. I don't even know everything I wish, but the knowledge I have, I am definitely willing to share with all of you. So one of the things also, because we're basically at the end of our webinar, is that we would like to thank you. We would like to thank you for participating today. So on behalf of Bracon, Saremco, and Dentiq, and myself, we would like to thank you for participating today. And I always finish every of my presentation slides, webinars, what I do, with one slide. And that is basically, if you want to follow us and want to know more about what we do, or how even our services and our knowledge can support you, please follow us on social media, on Instagram or Facebook. And I always say, money can't buy happiness, but it can buy a 3D printer. And for me, that's basically the same. So I really hope it gave you a good idea about the possibilities, what we can achieve with, for example, Saremco resins, how aesthetically it is, and actually you saw the results. We can really do some great work with that. I believe there's definitely been some questions coming up. So I would like to invite one of our panel members. He will help us with going through some of the questions.
Hi, so I hope you hear me now, Jeroen. Otherwise, you have to tell me that.
I can definitely hear you. Yeah.
Okay, that's perfect. So we got a couple of questions. One of the question I just answered before, because in the meantime, I was checking with Dr. Christoph Evers regarding the requirements and so on. So the first question is like answered already. So you see that in the chat. I go immediately to the next one. Jeroen, how does the accuracy of 3D printing compare with the milled restoration? Can you give insight to that?
Yeah. So Yeah, there are a couple of research for it. It's the accuracy of 3D printing is actually quite high, especially when you do the nesting correctly. And let me turn on my video because I don't think so. There we are. Yeah. So when we 3D print, we have to nest it correctly on our printer, and especially if something that goes up like vertically, and if everything that goes vertically is actually quite stable. The downside what we have when we do anything with milling is called actually the vibration or the deviation of the burr. So a burr spins what, 60,000 RPM, for example, and especially when you've got a thinner burr, it flexes more. So the thinner your burr, the more speed you have, it flexes more, and especially when you go through something and you have your feed rate, your burr is basically bending. Even your burr is going, but your burr is bending backwards actually because of the feed rate, the force on it. So the accuracy we have when we do something with milling can be completely different. So the research has shown that anything, and especially the fitting surfaces, for example, of crowns and implant cases, is 3D printed is just very, very accurate.
Thank you very much for this answer. The other two questions I will answer. The first one is like, will Saremco be working with formless printer in the future? I would love to say yes, but it's like, this is going to be on the roadmap to see which collaboration will be possible in the future with other printer manufacturers. We have now a long list of more than 50 different manufacturers right now. So this will be, of course, something from our main topics. And the next question is denture tech only usable on a SIGA? That's true right now. At the moment, it's only on all 385 nanometer printers from a SIGA available. And the curing is possible with the auto flash and the highlight power, these two devices. We're working on a new version of the denture tech material. So in the future, there will be coming something really, really, really improved.
Version number 2, huh?
2, exactly. So this will be, stay tuned that you get this information also with Bracon. Then the next question is, what software do you need to design a digital denture?
Yep.
Yep.
No, so there are a couple of softwares we can use. We can use, of course, the 3Shape. 3Shape has got a great denture module. The other one is Extracut. Those are the two main ones we technically use for dentures. There is a third one coming that is called Blender for Dental. Blender for Dental is a software, actually an add-on made by two South African brothers who live actually in Brisbane, Australia, who made an add-on part on the software of Blender. It works well, but it is very complex to learn. So my recommendation, if you really want to do something, look at 3Shape if you if you can, and otherwise Extracut, for example.
Perfect. Thank you very much for this answer. Then we have another question: is can it bond to normal acrylic, like for repairs, for example?
That's a very good question. No, the ones we have tried, not so much. So you can do small repairs with the resin itself. This is a very complex topic actually, and this is, again, some people who have different viewings on it. I'm more or less like, okay, if it breaks, it probably has broken for a reason. Find that reason and easily 3D print a new one. That's actually my philosophy on that one.
On the other side, Saremco is going to publish as well another innovation. It's going to be the peak primer. There's going to be like a base where you can like roughen the surface a little bit, so the relining will be something that works in the future as well. But this is also something we announce in a couple of weeks, maybe a month, depends a little bit. But then the next question is, what do you use to stain? But you said already, you're using the ELS paint art or the GC OptiGlaze and the polishing. Do you have to add something to this question?
Yeah, no. So what is important, for example, when you want to do anything like that, is just sandblast with the outside with a little bit of aluminium oxide, 110 micron. Yeah, 110 micron, 125 micron roughly, on a low pressure, so those particles you're not shooting it inside it, but you roughen up the surface, and that works really well.
Thank you for that. Another question is regarding the thickness, what you print on a SIGA, especially also for veneers. I got a question, I've done 3 cases, but the contacts are always tight and have to adjust. What do you finish the veneers with if you're doing veneers?
Let me see that question. What do you on 3 cases? It's always tight. Well, that's also a little bit tricky because most of the time it has to do with your settings and your dialing in. So I do find that a lot of the printers is personally I prefer to dial in my equipment even more to make it more accurate, because every time you get equipment out of the box, it is basically set up very conservative, so everybody can print or work with it. So I dial in my settings. So I've got different settings for printing, I've got different settings for milling or anything like that. So I do find that zero is for me is zero is a proper zero, and when I finish it, for example veneers, I just use a little bit of polishing and just a Scotch Brite to take away the little print lines what you have, then a little bit of a glaze over it or polishing, and you're ready to go.
Thank you, Jeroen. Another question, do you have a handout of many tricks and tips you have presented today? I mean, that's maybe something you have to do in the future, or we have to do in the future, like the small tips and tricks, maybe some videos where we can show that in an easy way.
Definitely. And otherwise, I would love to invite you to come to Melbourne. Hey, if you haven't been to Australia, that's a good trip for you.
So then I see, will Saremco be suitable to produce palatial veneers for wear cases?
Yes, definitely. What I do, for example, is if I understand your thing correctly, is yes, I've got a client, for example, on the other side of Australia, basically a 3-day drive, and I design it here. He's got an Asiga, and he puts it in, and we just put, for example, occlusal tabletops or anything, or anything just to thicken up palatal areas, and he just quickly 3D prints it, finish it, seats it, and we're ready to go.
Perfect. So I'm just checking if we have other questions, because you have like a lot of greetings and thank you messages from all the participants. So
always happy.
It seems like it was good.
I see one of the questions is, can you bond with Panavia? Yeah, Panavia 5, I believe it's called. Exactly. That is one of them that is definitely recommended.
Yeah, we also did the study with the University of Zurich with this one, so that's actually the one we recommend as well. But you can also use the ELSM from our restorative product portfolio, so that works as well. And yes, that's like, I think, everything. Do you see something else, Jeroen, like in the questions? I have one. How do you prepare fitting surface, sandblast, edge?
Yeah, no, it's just there is so sandblast. Then there is an I believe there's a bonding agent, a primer you can use, and then you use anything like anything. But I believe the recommendation is not to use a glasionomer resin or a glasionomer bonding material, but everything else like a Panavia. And then what was the other one you said again? That
the one from us, ELS.
Yeah. So that is, for the rest, it doesn't need any preparation.
No, I see we answered all the questions. I see there are still plenty of people like in the webinar and listening to this question and answer session. But at the moment, I don't see anything more. One last question. After that, we're going to end the webinar. This question is, can you do resin bonded breeches with it? I mean,
yes, but one of the things is very important, that you have enough thickness. That thickness is really critical with anything we make like that.
Good, perfect. So the last question, I'm going to answer that one because we're now at the end of the presentation of the webinar, the question and answer session. I'm really thankful that that there are so many people participating in this. It was really great. We recorded the whole webinar. We're going to publish it in the next couple of days on YouTube, so you can share it also with your friends, colleagues, and so on. If you have more questions, please do not hesitate to contact us or Dentiq Dental Services with Jeroen or Bracon directly. We're here for your questions. Thank you very much, and wish you
Absolutely.
Thank
you very much.
Have a good
My
night.
pleasure. Thank you. I'm going to use that one. You guys have a lovely day, the remaining hours for your Friday, and have a great weekend already.